Hi everyone, this time we are going to solve problem from bit masking practice section from HackerBlocks. The problem is unique number 2. So let's have a look at the problem statement. So it says we are given an array containing n numbers and all the numbers are present twice except for two numbers which are present only once. We have to find the unique numbers in linear time without using any extra space. And first line contains the number n, second line gives us n space separated integers. So this is the input format. So you have a number n followed by n integers, and this is what you need to print in the output, right? And we also have to print smaller number before the larger number, right? So let's see how we can implement this one, right? So the problem that we are going to solve is unique number 2. And let me give you one more example. Suppose if your array is something like this, 1 1 3 2 5 2 5 7, right? Okay, so this is the array, right? And you can see all numbers are repeating twice except 7. And let's say this number is this number is 3. Okay, so except 7 and 2, all numbers are getting repeated. Okay, or if this is the case, then you can see unique numbers are 5 3 and 7. So these are the unique numbers in the array. So our task is to find out those unique numbers, and we don't want to use any extra space, and we want to solve it in linear time, right? So we will do it in linear time and constant space, and we will make the use of bitwise operators. The brute force approach you can think of, you can make a frequency table and you can easily work that out, right? So we are discussing the optimized solution using bitwise operators. So let's say given all these numbers 1 2 1 2 3 5 7 and 5, let's say these are the numbers given to us, right? The very first thing comes into our mind is if a number is repeating twice, right? If a number is repeating 2 times, then if we do XOR of that number, if you do something like this 5 XOR 7 XOR 5, then bits of 5 will cancel out and you will effectively get 7. So let's do one thing. Let us remove all the numbers which are occurring twice. So in order to do that, we have to do XOR of all the numbers. So let's do 5 XOR 1 XOR 2 XOR 1 XOR 2. This will cancel out, and XOR 3 XOR 5 XOR 7. So 5 will also cancel out, right? So effectively what we will get in the result is XOR of 3 and 7. So the result will contain 3 XOR 7, and let's see what this XOR is. So 7 is this, 3 is like this, okay? And 3 XOR 7 is going to be 1 XOR, this is 0 0, this is 1, right? Okay, so this is what you will get after doing the XOR. Now our task is, and this number is 4, okay? So effectively what you have in your result is 4, okay, because this number is actually 4, right? Now from 4 you need to figure out the values of these numbers 3 and 7, right? This is what you need to figure out. So what observations we can make, right? So the first observation is this number can never be 0, okay? This number can be 0 only if the two numbers are same, because 3 XOR 3 can be 0, 7 XOR 3 can never be 0. This means this number will contain at least one set bit, okay? So this will contain at least one set bit, and this set bit is of very prime importance to us. So this set bit is very important to distinguish the two numbers, right? So we will first find out the position of set bit, at what position this set bit is present. So we will try to find out the position of set bit. So clearly 0, 1 and 2, this set bit is at second position, right? And this means at second position, out of all the numbers in the array, only one unique number has set bit, because this is the property of XOR, right? When you do XOR, then the set bit is 1 if it is present in only one of those numbers, right? So only one unique number has the set bit at that particular position. So we can write a function which checks if this number has a set bit at a given position, right? So we are now interested in, out of all the given numbers, what numbers have a set bit at this position. We are not worried about bits at other positions. So does 5 have a set bit at this place? So yes, the binary of 5 is like 101, so it has a set bit. Does 1 have? No, it doesn't have. Does 2 have? No, it doesn't have. Does 1 have? No. Does 2 have? No. Does 3 have? No. And does 5 have? Yes. Does 7 have? Yes. Okay. So out of all of these, only few of the numbers have a set bit at this position, right? So what we are going to do, we are going to make a list A. Okay, so we are going to say, okay, we will make a list A of those numbers which have set bit at second position. Okay, at second position they have a set bit. So we add 5 to this, we also add another 5 to this, we also add another 7 to this, and now you will do XOR of these, right? So once you do XOR, so this gives you 5 XOR 5 XOR 7, and you will get 7. Okay, this is what you're going to get. How do you find the other number B, right? So for that you can do two things. Either collect all those numbers in which the set bit is not present. So you can collect 1 XOR 2 XOR 1 XOR 2 XOR 3. So clearly this is 3. So this is one way. Another way is, if you don't want to do this thing, if you say, okay, I don't want to make another list, I know the one unique number. So this is our first unique number. So this is unique number A. And let's say the second unique number is B. So you know what is result. So result you have already computed. So if you take the XOR of result with the first unique number, that is 7, you will get the second unique number. So you will get B as result XOR A. So A is 7 and this is 3 XOR 7 XOR 7, which is 3. Okay, this is how you get the second unique number, right? So this is how we have found out both the unique numbers, and in the next video we will talk about implementation.